Today we are going to understand the next concepts of generics in Java. Just to recap, what is generics in Java and what we have seen. So basically, generics gives you the benefit of type safety. It allows you to avoid typecasting. It gives the benefit of early error detection because the errors can be detected at compile time instead of the runtime. And some of the examples here. This is the class data store, and this is how we define the generic types of a class. And similarly, for the methods, we have these kind of methods where we pass the types, and these types are denoted in this way. And for the arrays, you can define generic arrays in this way. So going ahead, whatever we are saying right now, this is unbounded generics or the types. When I say T here, it can be anything. There is no restriction basically. So if I want to restrict it, then how do I do that? So that's the goal of this video. Let's understand that. We'll take one example. You create one Java class here. Say compare utils. What is compare utils? Create a static method. I'm going to return value here, the mean value. What I'm going to take is these two values. So I have two parameters of type T, and whatever is the minimum of between these two, I'll return it. So you can see the return type is T. Okay. Here, if I try to do this comparison, right? Item 1 is less than item 2. It cannot be applied to T. Reason being, first of all, the method is not aware what type it will get. It could be a string, it could be anything else. So it is not aware because this is unbounded. So to make it bounded, we'll take the example of comparable. Here, I'm extending. Basically, when I say extend, all the classes which implements comparable, only those would be the valid types. That's the idea here. So when I say item 1 and item 2, and the classes which are going to implement comparable. So we know string, we know integer. So those are implementing comparable. And even your custom object class, even those would implement the comparable if you want to have a custom defined comparing logic basically between the two objects. So how we can do this is we'll take this item 1 dot compare to item 2. If it is less than 0, that means it is the minimum value, otherwise item 2. Simple comparison that we can do using the comparable. So any class which is implementing comparable will be using this. Now let's go to our app, and in the the S out over here compare utils dot main. Let's take 10 comma 20. Let's see the output. You can see minimum is 10. Now let's take floating point number here 10.5, 10.49. You can see it's giving the correct value. Now let's do string comparison. ABC, EQR. Let's check this out. As you can see, ABC is the minimum. So this is how it is now restricting this. Now to just demo how this is restricting, we'll create one person class, or say person class. This person class has two instance variables. Okay. We'll generate the constructor and also the letters and check. Yeah. Now we have this person class. Let's try to do the similar comparison what we have done for integer, for float, for string. Right. Now you'll understand how this bounded generic types work. We create the person class here. Name is A and age is 30. There is one problem here. Age is 30 and let's take one more person, new person, age is B, sorry, name is B, and let's call this compare utils dot name. When I call this, it doesn't work. As you can see, it is given compile time. It is saying the required type T. It does not match. Why it is not matching? If you look at the person class and if you look at the compare utils, we have said all the classes which implements comparable, but person class doesn't implement comparable. Hence, it is not a valid type. So let's make it a valid type using this comparable, and even comparable uses this generic, right? It is unbounded. It can be any type. Now let's implement the compare to method. We'll just say that it is integer. We compare h dot h comma o dot get h. Now if you see, the compilation error is not. All the classes which have implemented comparables are only allowed. Let's see the output. I have not implemented roasting method here. Let me do that. Okay. If I run this, we get AS, the person with less H. So this is how you can use the bounded generics, basically bounded types. We are restricting basically. Now let's take one more example. We will create num utils. We create some static methods. This is my T type, and let's do the sum. And we'll return double here. Sum of any type. So we'll take two items here. Okay. Now this is quite straightforward. Item 1 dot. See again, if I do item 1 plus item 2, it doesn't work because it is not aware which type will be sent to this method. So let's use the bounded types. So I will extend this to number because sum I want only for the numbers. Okay. You get the double value here, double value here, and when I do the sum, I should get the value here. Let's try this out. It is dot sum, which to the sum of 100 plus 300. So we can say we get 400, and I can do this similarly for any type, which is a number basically. 10.5f, 20.5f, floating numbers works fine. We can send long, we can send double, it should work. Either I have sent one floating number and one double number. It works fine because I'm converting them into double value and then returning the double here. And plus, we have these types, right? The T can be any class, which is a subclass of number. Any class, which is a subclass of number. So using this, we can restrict basically the type. So that's the advantage. If I try to do for strings, okay, it will not work. It is clearly going to say it is not a valid type. So this is the advantage that we get with the bounded. So that's all about the bounded types in generics. As you can see, I am doing list of. I'll create some method here. Add to list. It's create here only public static, and it returns nothing. But what I'm going to do is I'm going to take one input and list here, and this list basically I'll try to input add this value into the list. That is the whole objective here. Add to list. I just do list to add 3. That's it. Now here I will send hello. Where I guess sending this list here. Also continue. As you can see, hello is like that. Now let's make this as variable. What we have, right? Now when at this place, it doesn't know what is the type of list, basically, whether it's a string list, integer list, etc. And add to list, we are passing this list, particular list. So how does it infer that it's a string list? So it infers using this first parameter, the whatever you are sending here. So it works in that way. So this is type inference. So Java is smart enough to understand that this is a string list. And suppose if I change it to 100, say an integer list, see when this works. So you don't need to worry about it. It understands basically. Now let's take one more concept of type witness. Although Java doesn't need the type witness concept to be implemented, because after Java 8, it is able to identify the type. Let's understand from this example. Here I am returning the list. Okay, you say create new list. When I create new list, there will be no input here. I'm just going to return new array list. That's it. When I call this method here, create new list, will define like this. I want a string list. What I will do is string list dot add flow, English dot add void. I'll just print it here. It works fine. It was able to create the list. It was able to infer that it's a string list after once I add this value. So this is how things work. But now what we can do one more thing. Although it is not required explicitly, because Java is able to understand it, but you can pass something like this. So this is my static method, right, of this app class. That is why I've used this app dot create new list. I can directly call it because it's a static method, but for type witness, I need to add this. So this is app dot, and before calling this create new list, you put this particular type. Basically, you pass the type here that it's a string, and then it will make no difference. The output will be same. Let's make it integer. See, as soon as I make it integer, I get the error. So that's the advantage of type witness. So that was the concept of type witness. If you encounter this, now you would be able to identify that's the type witness in Gentex. Thank you so much. Have a good day.